Hello everyone, welcome to the channel Statistica Hub. So in this lecture, our topic is measuring variability and spread. Okay, so let's see this topic. Okay, so there is a very beautiful picture of a mother and her daughter on the screen. Okay, so the daughter is saying to her mother that don't worry about the dinner, mother. When you have an oven with a lower standard deviation, you will never burn anything again. Okay, so she mentioned this term lower standard deviation. What does this term actually mean is that she is talking about lower variability. Lower variability. She is saying that don't worry about the dinner. When you have an oven which has lower variability, then the food will not going to be burnt. Okay. So she is just trying to relax her mother that mom, just take a chill pill. Okay. Okay. So what does this term variability actually means? What does this term means? So if we define it in statistical terms, then variability describes how far apart how far apart data points lie from each other from each other and from the center of the distribution. Okay, now we have mentioned this term center of the distribution. Okay, so what does this actually means? That we are talking about the averages. We are talking about averages. Okay, so let's just take a very look at a very rough idea that what we are actually going to do and why does this variability matters. Okay, what is the use of it, how, why are we are studying it. Okay, so we have a particular kind of population. Okay, and from this population we have a sample, right? Okay, now by using the results of the sample, we are going to generalize our population. That's what we do. Okay, so first thing we need to do is to summarize our sample. We have a sample data and we are going to summarize it. Okay, now for the summary purpose, the first thing we do is to find the averages. That is my mean, median, mode. Okay, the averages. So what are averages is? Averages is the are the central tendency. We are going to find the central tendency, and averages do quite a great job for summarizing the data set. Okay, and they tell us that where the center of the data lies. Center of the data lies. That where most of the data points lies. That's what the central tendency tells us. Okay, now there is another term which we have done is variability. What does this say? It says that how far apart these points lies. That how far apart these points lie. Like it is like this, that this is the center of the distribution. Averages give us this particular value, uh, and how far apart they lie. This is variability, that this is how far apart the data points in the sample data lies. Okay, now this is important because the amount of variability determines how well you can generalize results from the sample to your population. Okay, now see it like this. If you have a low variability, if we have low variability, then in that case we can better predict the population, right? And if we have high variability, then in that case population will be the results would be less consistent at that time. They would be not that good because the variability is high in the results. Okay, so the variability actually define us that how well we can predict the results of the population from our sample data results. Okay, now let's just understand the concept of the variability by taking a very interesting example of a basketball team. Okay, now let's see this. So there is a basketball team. If you have ever played the basketball, then you know that let's see that this is my basketball court. This is the court. My drawing is not that good, but let's just consider it. Okay. Now in the basketball team, there are 5 players. There are 5 players, and these 5 players play according to the 5 positions in the court. These are the respective 5 positions. Let's consider that these are the 5 respective positions. What is the first position? First position is point guard, second one is shooting guard, third position is small forward, and fourth position is power forward, and fifth position is center. Okay, now these are the 5 respective positions in the team basketball court. Then okay, now what is the question is that due to some accident, they are a player down and they need a new team member. They need a one player for their basketball team. Okay, now what are the requirements for that new team member? The requirements for the new team member is that he has to be all rounder in these 5 positions, but the additional requirement, that the reliable requirement that the coach wants, is that he has to be a reliable shooter. Okay, that is the main requirement here, that the one has to be a reliable shooter. Okay, now for the one to get the reliable shooter, what would the coach do? The coach has performed some trials. Okay, the coach has performed some trials, and after conducting trials, he is down to 3 players. He has down to 3 players. Now the question arises that from these 3 players, which player should he choose? Okay, he is down to 3 players. Now after when he has conducted the trial, these 3 players have some particular kind of scores of scoring into the basketball. Okay, that is for the shooting factor, right? Now they have the scores. Now what we need to do, we need to compare the scores of these 3 players, compare scores of 3 players, and based on the scores of these 3 players, we are going to compare them, and then we will choose that which one is reliable for the team. Okay, now let's just see the scores of these 3 players and try to compare them. And how we are going to compare them? We are going to compare them by taking out the averages of these 3 players. Let's just take out the averages of the scores of these 3 players and try to determine that what does it says. Okay, now these are the corresponding scores of these 3 players. Okay, so this is my first player. Okay, now here it is given that points scored per game are here and frequency are here, and here frequency tells us that the number of games where the player got each score. This player scored 9 points in 2 games. Okay, it is 9 points in 2 games, and it is like 11 points in 2 games. Okay, now we have to find the averages, that is mean, median, mode. Okay, let's just find out the mean first. So if I denote it like this, then that would be my xi, and this would be my frequency, that is fi. Okay, so for the finding the mean, we have done this in the previous lectures too. So let's just find out the mean. That if I find out the mean, that would be sigma of fi xi upon sigma fi. This is the formula for the mean. So what will be the mean here? That is mu. Sigma fi xi. Let's just compute it. Fi xi. If I multiply these two, what would be that? That is 7, 8, 9 to the 18, 20, 22, 12, and 13. Okay. So what is sigma fi xi? Summation of all these. That is, I think 100. I have done it previously, so it is 100. Okay, so it is 100 upon what is the sum of the frequencies? The sum of the frequencies is like 10. Okay, so 100 divided by 10 is equals to 10. So this is the mean for the first player. We are talking about the mean. Okay, now what is the median? If I find out the median for the first player, what is the median? So as we know here, n is equals to 10, that it is the even number, and whenever we have an even number and we have to find the median, in that case the median is found at like n by 2th term and n by 2 plus 1th term average. Okay, the median in this case is the average of these two terms. Like what is my n by 2th term? It is like 5th term. and n by 2 plus 1 is the sixth term. Okay, so if I arrange these in the ascending order, this would be like 7, 8, 9, 9, 10, 10, 11, 11, 12, 13. Okay, which one is the fifth position? This is 1, 2, 3, 4, 5. This is fifth position, this is sixth position. And the averages of these two, 10 plus 10 divided by 2, that is 10. Okay, so my median is 10. Okay, now let's talk about the mode. What is the mode for this one? Mode is the one which has the highest frequency. Okay, which has the highest frequency. Now we can see that the highest frequency in this is 2, right? The highest frequency in this is 2. So my mode will be 9, 10 and 11 because the highest frequency 2 is for 3 points. That is 9 points, 10 points and 11 points. Okay. Now these are the three kind of data here that we have found it out. Okay. Now let's talk about the second player. This is my second player. When I talk about the mean, like we have done for the first player, this is my xi, this is fi, and we are going to find the mean for the second player. This is sigma xi fi. This is 7, 9 to the 14, 40, 22, 13. Okay, and the sum of frequencies is, I think 10. Okay, so and the sum of xi fi is equals to, what is this? I think 100 again. So the mean is 100 by 10. Okay. So the mean is here 10. What is the median here? The median here, as n is equals to 10 here, like the previous case, it will be the n by 2th and n by 2 plus 1th term average. That is 10 by 2 and 10 by 2 plus 1th term average, which is 5th and 6th term average, right? We are going to find the average of these two, that is 5th and 6th term. Now, for finding the averages of the 5th and 6th term, first let's just arrange them in the ascending order. Okay, so if we arrange them in the ascending order, it would be like 7, 9, 9, 10, 10, 10, 10, 11, 11 and 30. Okay, now which one is the fifth position? 1, 2, 3, 4, 5. This is fifth and this is the sixth position. So the averages of these two, that is 10 plus 10 divided by 2 is equals to 10, right? So the median here is 10. Okay, now which one is the mode? What is the mode here? The mode is the one which has highest frequency. So the highest frequency is 4 here. So the mode is 10. 10 points has frequency of 4. The mode is 10. So here mean, median, mode, all three are equals to 4. Okay. Now let's talk about the third player. This is my third player. Okay. Let's just see for this one that this is xi, this is fi. Perform this calculation like we have done for the other two. Okay, this is 6, 6, 14, 30, 11, 13, 30. Okay, and the sum of xi, fi is equals to, I think, 110. Let's just check the calculation. If I do it anything wrong, just cross check it. Okay, and the sum of frequencies is 11. Okay, so the mean for the third player is 110 divided by 11, that is 10. And the median, what is the median here? Okay, so it has n is equals to 11, which is the odd number, and for odd number the median is n by 2 plus 1th term, n by 2 plus 1th term. Okay, so what is this? That is n by 2 plus 1, that is 11 plus 1 by 2, 11 plus 1 by 2, that is 12 by 2, which is the sixth position. Sixth position. Now, which one is the sixth position? If we write it them in the ascending order, this is 3, 3, 6, 7, 7, 10, 10, 10, 11, 13, and 30. Okay. Now, which one is the sixth position? This one is the sixth position, that is 10. Okay. So, the median for the third player is 10. Okay. Now, what is the mode for the third player? That is the one with the highest frequency. The highest frequency is 3 here for the 10 points. Okay, right? So the mode is 3 here. Okay, now look at the results of all these three players. We got mean, median, and mode for the third player as 10. Okay, for the second player, we got mean, median, mode, that is 10 points too. Okay, and for the very first player, we got mean, median, mode, that is 10 points too. Okay, so here we see that all the three players have mean is equals to median, that is equals to mode. Okay, all these three have the same averages. Now, my point of concern is that what is that how can I choose the one player from these three? Okay, this is the main point of concern. The coach wants only one player. Then how can I choose one player from these three? They all have same averages. Okay, so we need some criteria to find that one player. Okay, now look at the scores of these three players. By looking at the scores, we can see that the scores that are being achieved by these three players are differently achieved. Okay, they have been achieved very differently. Like if you look at this way, then he has scored 8 points in one game. Okay, now in look at this point, he has scored 9 points in two games. Okay, and like this, he has scored 10 points in two games and he has scored 10 points in four games. Okay, and the when we talk about the third one, he has scored the maximum points, that is 30 points in one game, and sometimes he has scored 3 points in two games. Okay, so these scores have been achieved differently, they are not consistent. Okay, so we need to know the player which is more consistent, that has to be in the team. It is like we need to get the consistency of the player, because there may be a chance that he has performed very well in the first game, but didn't perform very well in the second game. Okay, so we need to get the consistency of the player at that time. Consistency of the player, that how consistently is the performance of the player is. Okay, now look at this. This is the basketball player scores. This is the frequency and this is the score. Now, this is the distribution that we have got. Now, we can measure the center of the data by looking at the averages. We have got the center of the data. That is for the three players, we have the center of the data. That is, we are talking about mean, median, mode. That is, three of them are equals to 10. They have same center of the data. Now, the mean tells us nothing about how spread out the data is. So we need some measure to tell us this. Okay, so it is saying that mean is only saying that where the center of the data lies. It doesn't tell us that how spread the data is. Okay, so we are going to consider the thing that we are going to check that how well the data is spread. Okay, so let's see it. Okay, so this is the coach here, the coach of the basketball team. Now he has some confusion, like all three players have the same average scores for shooting, but I need some way of choosing between them. Think you can help. Okay, now we are going to help this coach because all these three of them have the same scores. So we are going to talk about the spread of the data. That is spread of the data. Okay, now talking about the spread of the data, let's talk about the range. Okay, that is, we are going to use the range to differentiate between data sets. Let's see how we can do this. Okay, so for understanding this, let's see that what is the range and how we measure the range. Okay, now we can easily do this by calculating the range. Let's see it how. The range tells us over how many numbers the data extends, over how many numbers the data extends. So by saying it, we actually mean that we are going to measure the width of the data. We are going to measure width of the data. Range is basically measuring the width of the data. Okay, so to find the range, we take the largest number in the data set. Largest number in the data set. Okay, and this largest number is actually the upper bound. Okay, and subtract this largest number from the smallest number in the data set. Smallest number in the data set, and that smallest number is said to be the lower bound in the data set. Lower bound in the data set. Okay, so let's just see this by an example. So if we have this data set, I have this data set, and this has been arranged in an ascending order. And what is the lowest value, lower bound? That is the smallest number. 7 is my smallest number here. So this is my lower bound. Okay. And 13 is the largest number here. So this is my upper bound. Okay. So if I look at in this way, that what is my range here? My range is here is upper bound minus lower bound. Lower bound. So that is equals to 13 minus 7, that is equals to 6. Okay. So subtracting the lower bound from the upper bound gives us the range. Okay. Now this is a very simple calculation for finding out the range. So what is the range? The range is a way of measuring how spread out the set of values are. It tells us that how spread out the set of values are by subtracting the largest value from the smallest value. We have a rough idea that how spread out the set of values are. Okay, it's given by upper bound minus lower bound, where the upper bound is the highest value and lower bound is the lowest value. Okay, now let's just understand this by a problem. Let's do a problem and we will get a more clear understanding of this range. Okay, now it says that make a histogram and R values dispersed in the same way. Okay, so let's just try to make a histogram of this score. Okay, so we have this first score. Okay, if I make a histogram of it, it will be like this. My drawing is not that great, so the lines would be like uh, okay, so let's it here it comes the frequency. It is frequency here, and here comes scores. Okay, now we are going to, for making the histogram, we need continuous data, right? So we are going to perform it like 7.5, and this is like there are other numbers here too, that is 1.5, 2.5, 3.5, 4.5. So I am depicting it like here. Okay, 7.5, 8.5, 9.5, 10.5, 11.5 and 12.5. Okay, and the frequency is like 1, 2, 3. Okay, so because of the continuity in the data, we have taken it like 7.5, 8.5 and goes on. Okay, so for 8 score we have one frequency. So I will graph it like this, that is 7.5 to 8.5. This is my 8. So for 8 points I have one frequency. For 9 points we have two frequency. So here it is 9. So for 9 points we have this much of frequency. That's how we draw the histogram. Okay, for 10 points we have three frequencies. So the three frequencies here, it will be like this. Okay, for 11 points we have two frequencies. So it will be like here for the 11 points, and for 12 points we have one frequency, so it will be like this. Okay, so this is the histogram that we have for the first score. Okay, now this looks like very symmetrical kind of histogram. Okay, if I join the points, it will be like somewhere like this. Okay, somewhere like this. Okay, so this looks kind of very symmetrical data. Okay, so if I talk about the range of these scores, what is the range of these scores? So for finding the range, what is the lower bound? The lower bound of this data set is 8. That is 8. Okay, you can clearly see it. And what is the upper bound of this data set? The upper bound for this data set is 12, right? Okay, so if we find out the range, then range is 12 minus 8, that is equals to 4, right? Okay, now let's see it that what is the, which one is the another score that we have. This is my second score. Okay, now similarly let's perform let's draw an histogram for this one and try to calculate the range of this. Okay, like for the continuity of the data, like we have performed in this in the previous cases, we are going to do it like this: 7.5, 8.5, 9.5, 10.5, 11.5, and 12.5. Okay, and the frequency is like 2, 4, 6, 8. This is frequency. Okay, now let's just draw the scores. This is 7. For 8 points, we have one frequency. Okay, so it will be like, I'm sorry, it will be like this. Okay, and for 9 points, we have 0, so it will be here. And for 10 points, we have 8, so it will be here. Okay, for 11 points we have 0 frequency, so it will be here, and for 11, 12 points we have 1 frequency, so it will be here. Okay, so this is the histogram for the second scores, second type of scores. Okay, now what is the range for this one? For finding the range for this one, we have lower bound. What is the lower bound here? The lower bound is 8 and the upper bound is 12. Okay, so the range we got is lower bound, sorry, upper bound minus lower bound, that is 4. Okay, now look at this range. They both have, these both data sets have same kind of range. Okay, but the histograms of these are looking different. So we are trying to say that look, these results are, even though the data are different, these results are same. The range for this one is 4, the range for this one is also 4, but the data are quite different. Okay, so what does the we are actually saying is that both data sets above have the same range. They have the same range, but the values are distributed differently. And because of the distribution of these sets of values, we got one histogram like very symmetrical like this, and the other is like this one. That is not that symmetrical. Okay, now because of, and this is due to the variability in the data. Now I wonder if the range really gives us the full story about measuring spread. Okay, now the question is that does the range really gives us full story about measuring spread? So range basically gives us that range, range describes us the width of the data, right? Width of the data. It only describes the width of the data, not how it's dispersed between the bounds. Not how it is dispersed between the bounds. Between the bounds. Now is difference in saying these things. It is like this is my range for the data sets. It is like 8, 9, 10, 10, 11, 12 and 12. Okay, now we know that this is lower bound, this is upper bound. Okay, now we are subtracting the upper bound from the lower bound. Sorry, we are subtracting lower bound from the upper bound. Okay, now we are only using the upper bound and lower bound values. We are not using the values that are in between them. Okay, so we don't know that how values are distributed between these bounds. We don't know. If I give you any value, let's say if I give you that the range for a particular kind of data set is 10, then you don't know that what is the, that how these values are distributed between the bounds of these range. Okay, so the problem come here is that both sets of data have the same range, but the second set, that is the second set, has outliers. That is this one. This set has outliers. That is, outliers are what? Outliers are basically extreme high or extreme low values. Whenever we have extreme high or extreme low values, these values are said to be the outliers. So it looks like the range can measure how far the values are spread out, but it's difficult to get a real picture of how the data is spread. Okay, now because of the outliers in the second case, we have the graph that is not like that much satisfactory. Okay, but the range for these are exactly same. Okay, now let's look at the story of these outliers, that how does these outliers affect us. Okay, so basically, range is a very simple way of saying that what the spread of a set of data is, but it's often not the best way of measuring how the data is distributed within that range. Okay, now if our data has outliers, let's look at this. So imagine this is the set of data that we have. Okay, this is the set of data. Now it has lower bound of 1 and it has upper bound of 5. Okay, now here these numbers, we can see that these numbers are fairly evenly distributed between the lower bound and upper bound, and there are no outliers for us to worry. Okay, now the if I find out the range for this one, what is the range for this one? That is upper bound, that is 5, minus lower bound, that is 1, which is equals to 4. Okay, now if my data has outliers, in that case using the range to describe how your values are dispersed can be very misleading, because range is range is sensitive to the outliers. It is like very sensitive to the outliers. What is outliers? Is the ex either very extreme sorry, they are high extreme or high low values. Sorry, they are like extreme high or extreme low values. I'm so sorry about it. Okay, so outliers are like extreme high or extreme low values, and we use the calculation in the calculation of the range. We use upper bound, that is extreme high value, and lower bound, that is extreme low value. So if we have outliers, that is extreme high or extreme low value, they are going to be included in the calculation. Okay, now because of these, the outliers are so sensitive, the range is so sensitive to the outliers. Okay, so if this is the data set that I have, and if I add the outlier in it, okay, that is, we add any outlier in it. So let's just look at this data. We have one like 3 times, we have two 4 times, we have three 5 times, we have 4 times, and we have 5 3 times. If we make a like vertical line bar chart of this, like histogram type, okay, and these are the, it would be like 1 2 3 4 5, and this is 1 2 3 4 5. Okay, let's just make a graph of it. So if we make a like line chart of this, then how would we make it? It has one has got the frequency of 3, so it would be like this one. Okay, 2 has got the frequency of 4, so it would be here. 3 has got the frequency 5, so it would be here. 4 has got the frequency 4, so it would be here. And 5 has got the frequency of 3, so it would be here. Sorry, it would be here. Okay, so this data looks quite like fairly evenly distributed. It is like very evenly distributed data. Okay, now let's just look at the data when we add an outlier to this data. If we add an outlier to this data, let's just look at that case. Okay, so this is the case of outlier. We have the same data, but the upper bound has increased to 10 because we have added the outlier 10 in this data. Okay, now let's just look at the range of this data set. We have the lower bound is still 1, the lower bound is still 1, and because of the outlier, that is the extreme high value here, the upper bound has changed to 10. Okay, so the range would be upper bound minus lower bound, that is 9. Okay, so we can see that the range has increased to 5 points, because the previously we have range 4 and now we have range of 9, so the range has increased by 5 points. Okay, now if you look at it like by the graph, then it would like 1 has the frequency of 3 and 2 has the frequency of 4, 3 has the frequency of 5, 4 has the frequency of 4, 5 has the frequency of 3, and 10 has the frequency of 1. Okay, now let's just make the graph, that is 1 2 3 4 5, and there are some other values in between. Okay, 5, 6, 7, 8, 9, and this is my 10 values. Okay, and 1, 2, 3, 4, 5. Okay, now 1 has 3 frequency, it would be here. 2 has 4 frequency, it would be here. 3 has 5 frequency, it would be here. 4 has 3 frequency, 4 has 4 frequency, 5 has 3 frequency, and 10 has 1 frequency. Now look at the graph of this one. Okay, now without the outlier, the two sets of data would be identical. Okay, now the second set of data has outlier, that is 10, and this is the outlier here. This is the outlier here. We can easily see this on the chart. If we draw the chart, then we can easily see this, that this is the outlier here. Okay, now we can see that just because we add one number, that is 10, we added one extra number, that works as an outlier here. Outlier here, the range is extremely sensitive to the outliers. Okay, now without that outliers, they are like so much identical, they are just the similar way. Okay, now the question arises is, so is it a bad idea to use the range then? If it is so sensitive to the outliers, then why are we using it? Okay, now the answer to this is that the range is a great and quick way to get an idea. It is a very quick way to get an idea of how values are distributed. Distributed. Okay, but as we know that everything has its limitations, so the range is a bit limited. The range is a bit limited too. Okay, now the range tells us that how far apart your highest and lowest values are, but that's about it. It only provides a very basic idea of how the values are distributed. Okay, because the range is calculated using the extreme values, it's impossible to tell that what that data actually looks like. Okay, okay, it's like whether it contains or outliers or not, you can't say it by saying the range. Okay, it is like if I say the range is 15, you can't say by looking at the range that whether that data would have outlier or not. Okay, so basically the range is like very quick way to get an idea, but it's a bit limited because of its sensitivity to the outliers. Okay, now the question arises is that if the range is so limited, why do people use it? Why do we use it if it is so limited to outliers? Because it is so simple. Because it is so simple. It's simple. The range is so simple that it is easily understood by lots of people. It like, what do we have to do? We have a data set. We just have to subtract the highest value from the lowest value. It is so simple to calculate. If you talk about the range of ages, if we talk about range of ages, like it is like 2 to 12. What is the range for the 2 to 12 ages? That is 10. Okay, for example, people will easily understand what are you actually trying to say by telling the word the range to them. Okay, but sometimes if you talk about the range, then sometimes actually the range is so misleading because range are so damn sensitive to the outliers. Okay, and they give quite a misleading impression of the data. Okay, because of these because of the limitation of the range. Okay, now we have understood the concept of the range. In the next lecture we will see that how we can overcome the this outlier topics of the range. Okay, how we can like how we can try some another way for to get away from these outliers. Okay, so that's all for this lecture. Thank you.